falls on the sensitive what? Cells. That's what we said. Huh? What was our last point? We say yes, refracted light falls on the sensitive cells. They generate electrical impulses that travel through the optic nerve to the brain. That travel through the optic nerve to the brain. Did you find out where he is or something? That travel through.
So he said he's having problems connecting. So
The optic nerve to the brain. That travel through the optic nerve to the brain. Clear? It's very easy. Your light is refracted onto the fovea. The fovea generates electrical impulses. The electrical power impulses travel through the optic nerve. You look at the diagram, if you have drawn the diagram of the eye, to the brain. The brain generates the image that you see. Huh? The brain will generate the image that you see. It's the brain that will calculate and generate the image that you see. This happens in less than a fraction of a second. This happens in less than a fraction of a second. Are we together? Subheading accommodation. Same spelling as accommodation for housing. Accommodation. Accommodation from your syllabus. Who can define accommodation? Those that have been reading.
What's the subheading, sorry?
Accommodation. Accommodation. Is Noku in the lesson?
Accommodation of what?
Is Noku in the lesson? We are under the human eye. Simply accommodation. Is Noku in the lesson?
Yeah.
Okay. Who can define accommodation? Please don't tell me about the houses. We are talking of the eye here. What is accommodation? Someone, you guys, I said go and read. Kuda, what do you think is accommodation? What is accommodation? Someone else.
Isn't it the angle at which the light rays hit the
Not really.
eye?
I get your point, but not really. It's simply the ability. Accommodation is the ability of the human eye to focus on distant or near objects. Simple definition. Accommodation is the ability of the human eye to focus on distant or near objects. On distant or near objects. The ability of this human eye to focus on distant or near objects. Clear? Under accommodation, write that every light ray that hits the eye, every light ray that hits the eye needs a certain amount of refraction. Every light ray that hits the eye needs a certain amount of refraction. Refraction is bending, huh? Needs a certain amount of refraction in order to be directed to the fovea. In order to be directed to the fovea. Are we together?
Yes, sir.
The eye lenses, the next point, the eye lenses have the ability to widen or narrow. The eye lenses have the ability to widen or narrow. To widen or narrow. Have the ability to widen or narrow, in order to make sure that the light hits the retina at the right spot. In order to make sure that light hits the retina at the right spot. Clear? Light from a closer object, light from a close object, light
So
from
I don't need
light from a close object.
for that. Sir.
Where were you? That's what. Hi, boss. Hello. Muraidi. Muna chakati mode yachana. Ndekubiko. Azari kuchabari kumajisa. Ari nani. Amwasu chema. Manyoni. All right. All right, PY. Those in the lessons, I got PY go. And I saw that the chema. Eh? Andy Friday. Saka PY. Well, sorry guys, sorry. Sorry about that. Where are we? Someone was asking me, they were lost on the last point. What did we say?
So you said the eye lenses have the ability to widen or narrow in order to make sure that the light is, that's the part I didn't.
The light hits the retina at the right spot. A light from a near object, I will show you just now in terms of diagrams. The next point, light from a close object, light rays from a close object are diverging, spreading out. Diverging means spreading out, clear. Light from a near object are diverging. Light from a near object are diverging, in brackets, spreading out. They need to be refracted inwards. They need further refraction. They need to be refracted inwards, so they need more refraction. They need to be refracted inwards to be focused on the retina. It will be focused on the retina. Clear? So what it means now in terms of diagrams,
But you said they need to be.
refracted inwards. So if you've got your human eye there, I'll just draw a diagram because you know books. So I've got a close object here, close to the eye. So what we are simply saying here, in fact, I'll use just a point here. Let's say like this here, close to the object. So I mean, we are talking of this, was it's diverging like this. So in terms of these lenses here, the lens must become very thick. If I'm looking at something, why? Because I need more refraction so that I focus on the what? On the retina, clear? So these lenses, they become thick, clear? They thicken so that I have more refraction, clear? So let's look at what happens when focusing on a near object? Let's start from there. What happens when focusing on a near object? What happens when focusing on a near object?
Essa só quer saber, né?
Yes, yes. What happens when focusing on a near object? But who remembers what is attached to the lenses? Who remembers? Say what is attached to the lenses? Two things are attached to human lenses. What is that? You're forgetting what is attached to human lenses?
The
There are two
pupil.
things. No, pupil is here. The human lens here, what is attached to it? There's nothing to do with your pupil is here. There's nothing to do with what happens here. I even drew the other day like this. I said they are suspensory ligament and ciliary muscles. Suspensory ligament. Check your diagram. In your book, didn't you draw that? Suspensory ligament, the suspensory ligament and ciliary muscles. Suspensory ligament and ciliary muscles. Now, suspensory ligament and ciliary muscles. Now, when these are ciliary muscles, at the end here. So I need to explain something here. When ciliary muscles contract, when ciliary muscles contract, by contraction, they're actually moving upwards. When they contract, they move upwards so that this becomes thick, clear. So suspensory ligament, number one. Suspensory ligament contract, we're saying what happens, that's what the subheading. Not suspensory ligament, sorry. Ciliary muscles, suspensory ligament can never contract, they are not muscles. That's wrong. Ciliary muscles contract by moving upwards. They contract by moving upwards, clear? By moving upwards. So if they move upwards, they make this thicker. They force this to widen, clear? They clear? They contract. Then these
What you said, ciliary
ciliary
sorry,
muscles contract by moving upwards like this. I'm showing you the direction. These ciliary muscles, they contract. The contraction of that is moving upwards like this. To force the lenses to widen, because you want the lenses to be thick. Clear? Suspensory, sorry,
Okay.
ciliary muscles. Ciliary muscles contract. Suspensory ligament here. What happens to the suspensory ligament? We said they are not muscles, they don't contract, they don't, we talk of tightening and loosening. Do they tighten or do they loosen? If we want this to be thick here. This has pushed it. So these ones, what should happen? They should what? They should loosen, so that they allow this to move further. So they loosen. So you write that suspensory ligament loosen. Is it making sense here? Okay, let me draw a lens here. So I'm saying there are some fibers here that I'm talking about that are not muscles, like this. Then I'm saying after that, there is what we call what? Ciliary muscles. So I'm saying contraction of ciliary muscles is moving in that direction, so that we force this to widen. But now this has to what? To relax. Because if they tighten, this cannot further what? This cannot further contract. Is that making sense? So these here, ligaments here just need to loosen up, clear, so that they allow this to further cause the. So we are saying suspensory ligament loosen, and the lens widen or they become thick. The lens widen or become thick. Clear?
But can you repeat the point? Because I never got to write it because it went out.
We simply say ciliary muscles contract by moving upwards. Ciliary muscles contract and suspensory ligament relax. so that the lenses can widen and become thick. So that the lenses can widen and become thick.
So that the
Lenses can widen and they become thick like this. Why thick? Because we want more refraction. This light, we said light is diverging. So we want more light we want more refraction so that it focuses on this here. It doesn't miss this point. So this here has to become thick. They widen, or they become thick. Is that clear?
Okay. Yeah.
Yes, sir.
That's what we are talking about. And never mention in an exam that suspensor ligament contract. They are not muscles. They are what contracts are muscles. Huh? So these are ligaments. They only loosen or they tighten. Clear. So if you talk of suspensor ligament contracting, you are lying or relaxing. They loosen or they tighten. In this case, we are saying they loosen. Clear. They have to loosen because this is moving upward so that you can force this. Huh? Clear. Are we together? Because if they remain tight and this is trying to push this, then we don't achieve what we want. We want this to be able to change shape so that it widens. But now if they remain tight, then this, even if this is contracting, it can't go further because this is tighter. So this has to loosen. Is that making sense now? The suspensor ligament have to loosen. Are we together?
Yes, sir.
Making sense now?
Yes, sir.
So that more light is refracted. So that more light is refracted. So that more light is refracted correctly.
So become thick so that more light is refracted.
Yes, correctly. Onto the retina.
Okay.
Making sense now. Let's look at so far in subheading, looking at a far object. We looked at near object. It's the opposite of what we're talking about. Looking at a far object. Looking at a far object. Looking at a far object. So if we look at if we are looking at a far object, what do you think? Far object, an object that is far away.
Ciliary muscles expand.
So number one, when focusing on a far object, the light rays are almost parallel. The light rays from a far object are almost parallel. Therefore, they need less refraction than focusing on a near object. The light rays are almost parallel from a far object. Therefore, they need little refraction compared to a near object. Therefore, they need little refraction compared to a near object. They need little refraction compared to a near object. And then the next point is that suspensory ligaments, ciliary muscles relax. Ciliary muscles relax. Because now this has to become thinner. Ciliary muscles relax. Suspensory ligament tighten. Suspensory ligament tighten. The lenses become thin or narrow. The lenses become thin or narrow. When this the opposite, we want them to be thick. Yes. Ciliary muscles
Ciliary muscles
contract,
suspensory
relax.
ligament.
Ciliary muscles relax. And suspensor ligament tighten. Tighten, causing the lenses to become thin or narrow. Thin or narrow as less light needs to be refracted. Clear? As less light needs to be refracted.
So can you please repeat the last one?
Which last part?
Suspensory ligament tightens.
Tighten, causing the lenses to be thin or narrow as less light needs to be refracted. Are we together there?
Yeah.
Is Sarah in the silence? Are you there? Is Sarah there in the lesson? She's quiet. Oh, she's writing us. Now, there, that's what we've talked about so far. Now, having mentioned that, now let's look at what is short-sighted and long-sighted. Who knows what short-sighted is? Maybe some of you have got that problem, I don't know. I saw someone wearing glasses the other day. Short-sighted, what does that mean?
You can't see things that are
Short-sighted, you can't see from?
far.
From far.
You can't see things, yeah.
Yes, from distant. So short-sightedness, you can write that. You can't see from far, that's correct. Short-sightedness, you can't see from far. Short-sighted, you can't see from far. Short-sighted. So what do you think will be the problem if you can't see far from what we have just talked about now? What will be the cause of short-sightedness? You can see near objects, but you cannot focus properly on distant objects. Huh?
Your ciliary muscles can't contract. Or they always relax. No, sorry. Your ciliary muscles.
Remember, if you want
Fine.
to look at this, if you want to look at near, yes, you've got a point. If you want to look at a near at a far object, we said the lenses have to be thin. Huh? Have to be thin. That's what we said. Huh? So what does that mean? It means your lenses are too thick. Huh?
Thick.
Yes.
Okay.
They are too thick and curved. So the short-sightedness is caused when your lenses are too thick and curved. Short-sightedness are caused when your lenses are too thick and curved to focus a distant object. Clear? To focus a distant object. So they are too thick. So let me write a diagram. Of course, you can draw a better diagram of what we're talking about. So you've got your lenses here, which are a bit too thick. They're trying to focus on a far object. So now they are now it's like your image is being formed before you see the problem with this. This should happen at where? At the retina, so that the image is calculated, but this is happening before. Can you see that? Is that making sense? So you can't see anything. Huh? Are we together?
Yes, sir.
Making sense or not making sense? So how should we correct
Glasses.
Lenses?
Glasses.
Yeah, glasses. But no, we talk of lenses. Huh? What lenses do you use? Lenses. What lenses do we use? Yeah, I'm saying what type of lenses should we use? What do you think? You have looked at the problem.
I don't know, lenses that would make the image look near or something.
What
So do
type
you
of
mean
lens?
something like,
Yes, you want to say something? You want to
like
ask?
you're supposed to have thin lenses?
No, in physics, how many lenses did we learn? What type of lenses did you talk about in physics? I thought we talked about only 2 types of lenses. Didn't we talk about 2 types of lenses in physics? Because I do physics. Didn't we talk of a diverging lens and a converging lens? Yes. So we use a what? A diverging what? We use what type of lens? A concave. There's a concave and convex. Huh? The other one diverges lenses. So there, we use what is known as a concave lens to correct that. A concave lens. It's a concave lens. Yes, we use a concave lens for that correction because a concave lens is what is used to correct that concave lens, so that when we do that correction now, it will cause more divergence so that this will reach exactly what we wanted. Concave lens. Your glasses that you wear, they've got those concave lenses, huh? If you are short-sighted. Are we together?
Yeah.
Or not together? Or you are lost somewhere?
No.
Jungle. Now let's look at long-sightedness. Long-sightedness. Long-sighted is when someone can see what? What is long-sighted? Someone can
Images
see
far away, but
yes,
see stuff close.
yes. When someone can see images far away, but they cannot see objects very close. When someone can see objects far away, but cannot see objects very close. This is normally when the eyeball is too short. This is normally when the eyeball is too short. So the distance between the lens and the retina is too small. So the distance between the lens and the retina is too small.
The eyeball
is too short. So the distance between the retina, and the lenses is too small. So you miss out like this. Clear?
Yes, sir.
Yes, sir.
Zaji Yasin has managed to join. We're saying yes.
I joined long ago, sir.
He was lying about the network. Okay.
I said I joined long ago.
Okay. It's also caused by a loss of elasticity in the lenses. It's also caused by a loss of elasticity in the lenses. Elasticity in the lenses, meaning it cannot become thick enough to refract more light on the retina. is also caused by loss of elasticity in the lenses, meaning it cannot become thick enough. It cannot become thick enough to focus light rays on the retina. So what type of lens do we use?
So
We said
please repeat.
it's caused by elasticity. That's what we said, which is loss in that, which meaning it cannot become thick enough to focus on the retina. This is normally caused by old age. Yeah? So the guys, you've seen most guys that are old, it's difficult to read. Is that true? Most of your parents or our parents, if they reach 60, 70, they're now wearing glasses clear. Do with age,
Yeah.
it's due to that loss of elasticity in the lenses. So it's no longer becoming thick enough to focus more light on the retina. Are we together?
Yes, sir.
So how is it collected? What type of lenses? What are the opposites of what you said?
Convex.
Convex lenses, correct. Convex lenses is for more refraction. Convex lenses. Convex lenses, so that we have more refraction. Clear? Convex lenses. So we use convex lenses so that we have more refraction. Now what's simply left is the control of light intensity. Then we are done with the eye. That takes like 5 minutes. Clear? So we see you tomorrow. And have your, before Mr. M, your 15 minutes lunch also.
Thank you, sir.
Okay.
Thanks, sir.